And that was the first time I saw the foundry. Dark, dirty, dangerous. That's what they call it. Sand, we can still find a way to dispose, but how to dispose dust? We found somewhere that plastic could be used as a bonding agent for dust. And that's when we started trying with plastic and combining the two.
The beauty about the SPBs is that I could literally send it back to the shredder, recast them, remold them into another shape, and then that takes, a new life altogether.
Welcome to Mindful Businesses, presented by Sarani, and I'm your host, Vidya Iyer. In our podcast, we bring to you brands which are mindful in their practices and processes. A mindful business adopts and employs sustainable social, economic, and environmental practices. Today, we have with us Manish Kothari, Director of Rhino Machines, and Shridhar, the partner at R+D Studios, Silica Plastic Blocks. Welcome, Manish and Shridhar. Manish joins us from Anand, Gujarat, and Shridhar joins us from Gurgaon.
Thank you for having us.
Thank you.
So, humankind have been using metals since the Neolithic age. The earliest piece of metal made by humans, it was a copper axe, which was found and estimated to be anywhere from 5,100 to 5,300 years old. All kinds of metals have been cast and forged. What exactly is a cast? What is casting, Manish?
Casting is basically when you convert the solid material into a liquid form and pour it into any shape, which is the shape which you put in the mold, and it forms that. So it gets casted in a shape, and that's why it's called a casting. So it can be a earring, it can be a brake drum, it can be a small part in the nose, anything.
So what do you use to make the mold? There are different ways you can make the mold, right? The casting.
There are molds which can be permanent. They are made from metallic materials, and there can be molds which are non-permanent. And majority of the castings go into the non-permanent because they can easily reused and recycled. And almost 70% of them are made in sand, which is the most flexible material, because what you need in the mold is a refractory property. It needs to withstand the temperature. So the molds are made out of 70 to 80% are made out of sand, using different binding elements depending on the metal and the metallurgy and the process requirements.
So the way I'm visualizing it is that, say I need to make a mold of a cell phone cover, very easy one, and I would create a negative image of it on a sand piece, which then you would pour, say, either plastic or say I want a metal case, and I would be able to make my cell phone cover. Does that make sense?
Yeah, that's how it happens. So you make a negative impression of what you want. And to make the negative impression, you have a dye or a pattern, which is the positive impression. So from the positive impression, you make a negative impression, and then you pour liquid metal into that negative impression, which forms the shape which you have designed when you want to make a cell phone cover. So you'll have that negative impression formed inside, and it will take that shape.
So has this process remained the same, or has it changed over the thousands of years humans have been casting and forging?
Yes, the principal elements have remained the same. So sand has been one of the most common element across for centuries. What has changed is the binding agents which are used for bonding the grains together. Because when you're pouring anything which is liquid, it has to hold its shape. To hold the shape, you use different kinds of binders. And there may be a different grades of sand also, some which will be having a high refractory like chromite sand, or some which have basic properties like olivine sand. But majority again goes back to silica sand, which is found on the beaches, which is coming from riverbeds. And more recently, it has been started to get mined also. So it's coming from quarries by crushing. So there are three key resources of sand coming from the natural resources. So that has been the common element from centuries.
So you said this sand is recycled. So what percent is recycled or reused?
So every process, again, as I said, there will be a ratio. One of part of that mold, or major part of that mold, is the silica sand, right? Mm-hmm. So we'll go slowly to the major process over here. So if we have got 100% of casting, so we move to 70% are being done by the sand process. And in that sand process also, you'll find A majority is done by a more common process using clay. So in all these processes, your 85-90% sand goes back, the silica sand goes back into the system in a normal, simple way. So you just sieve it and reuse it. But between 5 to 10%, you have to introduce new sand.
So the whole casting process is not a basically eco-friendly process, but we need all these things. So what was the problem that you saw? The 20 or 15 or 20% that's not recycled, or of the silica waste that was not recycled?
Yeah.
What was the problem that Manish you saw?
So when we say that 5% of the sand is new, so as a percentage it looks very small, but when you start connecting to the volume which is there, it's not so small. So let's say India produces around 12 million tons of casting every year, right? 12 million tons of casting every year. This is something which is surveyed by the casting census every 2 years. Every 1 ton of casting is consuming an average of 800 kg to 1000 kg of new sand. Now, though I am recycling and getting 90-95% recovery, that 5% is not small.
Right.
And out of that 5%, very less quantity is being recycled as on today because of the limitations of cost, process limitations, or technology limitations.
You've been in this business for a really long time. How long have you been in this casting business?
So I've been in this business for more than 30 years now. The first entry into the foundry was when at the age of 18 or 19, when I went to a foundry after school. And my father said, why you have some 6 months break? That was in 1986. Why don't you go and commission a plant? And that was the first time I saw the foundry. Dark, dirty, dangerous. That's what they call it. And it was actually like that. And where is this darkness coming from? It's coming from the dust which was flying out of the sand process. So when you walk inside a foundry which is not with a good pollution control or well designed, you'll go in white and you'll come out black. It's how we describe foundry. And so this is something which is very deep inside that this is my industry. I was part of this industry, and I was always thinking why this foundry industry, which is the mother industry. You cannot work without this industry. And you have also said it's going to medieval times or ancient times. So why is this foundry can't be as clean as a normal business, or something which was always on the back of my mind.
So what challenged you to do this? Like what happened? What was the trigger?
The trigger, so we have been, the sand reclamation or recycling. So it goes back from my father's vision also when he started the business. I'm a second generation. I'm not the first generation. So my father, Shridhar Rao, he started this business, and he was always talking about recycling and improving resource efficiency, even when I was very young. And it was in 1998-99, that was the first time we did a sand reclamation for a sodium silicate sand bonded process, and it was patented. So it goes back so long that reclamation was always one of the agendas of how to recycle. And because green sand process, as we call it, which is based on bonding of silica sand with bentonite, that is called the green sand process. And it is used fresh. That's why it's called green. It's not green in color.
Or not even green in a good way,
No.
like sustainable. In fact, you're harvesting more of the sand.
Yeah.
Taking fresh sand. Yeah.
Yeah. So that, of course, whether it's in a good way or the bad way is a comparative thing which we can discuss at another time, whether it's good or bad. But it's one of the more efficient processes today, which is using more of natural materials and is recyclable. So this has been my core strength of understanding this process, green sand process. And there's a learning which I got from two mentors. One is from my father, and another is a French technologist, Renzo Capelletto, who explained to me the entire cycle of sand. And he would say that this is the amount of sand which goes out from here, this is the amount of sand which goes out of here. So at the back of the mind, this was always there. And so it is not that it happened suddenly. And as part of that business model, and we went into sand reclamation as an extension of our sand handling system. We went into sand reclamation to recycle the sand. From that sand reclamation came the next, which led us to the Silica Plastic Block. So it was a progressive into that direction.
Right. But there are other ways to do the casting now, right? What is the electromagnetic way?
See, there are some specialized processes. I can tell you there will be around 20 methods of making a casting. So it would become it would be a foundry training lecture.
Right. But not necessarily that one way is better than the other. So though it says electromagnetic, it seems like it is more green, but it's not necessarily
Not necessarily.
Okay.
We need to do the mapping of the entire process.
So tell me how you came about the vision of using it for building homes or building structures or even the brick.
So the brick is again, or the block as we call it, was a result of one of our customers saying that I want to make my foundry zero discharge and make it sustainable as a green foundry. So they had 90% recovery, 95% with their own plant. Then they put up a sand reclamation plant, which was bringing that to 98% or 97%. What remained was the 2 to 3% dust. So earlier, sand is not so difficult to dispose because this is not very aggressive in nature. Of course, you cannot do farming on this sand, but it's also not very acidic or alkaline. It's a very mild use of chemical. They said, see, sand we can still find a way to dispose, but how to dispose dust? So I will buy your sand reclamation plant only if you tell me a solution for the dust. So it was a customer demand. And it also connected with our own mission of waste recovery because we were moving from energy efficiency in handling to waste recovery by recycling the sand. And this became a natural progressive idea of making this 100% recyclable, which would put us in a different position as a market position also, because we are not talking only of a simple brick and mortar. You buy the machine, you put the machine and you run the machine. So we are talking of partnering the customer to help them make their foundry sustainable.
It all depends on the actual product. What is the product and what's the most efficient and the best and the cost-effective way of getting to that product? Whether it's using a traditional cast technique or electromagnetic technique or a 3D printed technique, it's a business call in terms of how you want to approach it.
So the dust is different than the sand. Dust is, how small is it?
Dust is, talcum powder. Mm-hmm. It will have the same feel.
Wow. But it's black and extremely...
It's black. And only the color, it's not white in color, it's black in color. But the fineness is similar. So there may be... So it's not only dust. We said that whatever cannot be reused, or there may be some sand which is burnt over a period of time. So there may be small grains or there may be some coarse grains. We said the system should be open to accept this wide variance. It can, whatever is not usable in the foundry, whatever is going to be dumped outside the foundry, that should be able to get consumed in this process. And so sometimes we would have blocks made from 70% sand, old sand, unusable sand. And we made blocks with 70-80% only dust. So the sources, the input has a wide range of variation. And today we have extended this beyond foundry, and we have got samples from Tata Steel, from the steel plant, of their slag dust. That has been tested. We have taken dust from the marble cutting or stone cutting industry. That has been tested. And we are now processing dust from a grinding clutch manufacturing company. That is getting tested. We are testing dust from a boiler plant, ash, and we have already made some blocks. So it's not limited now only to foundry. It has gone beyond that.
And what is the other component?
So the other component, when we started, we thought we'll put it combined with fly ash and cement, because that was already being done. But we were able to consume only 5 to 10% of our dust. There were some trials which were done with the red clay in Coimbatore. I went and met them. That was 15-20%. So it was not solving the problem of consuming the dust in a large proportion. And while we were searching, so we have our R&D team and we were putting and searching, we found somewhere that plastic could be used as a bonding agent for dust. And that's when we started trying with plastic and combining the two.
So you're solving the problem of waste plastic and waste dust grown from silica to even the quarries where they grind the stone. So where does Shridhar fit in this whole equation?
Well, my journey with Silica Plastic Block, or SPB like we call it, started when Manish called us over to redesign the master plan for the factory. And in doing so, we visited the entire length and breadth of the factory and realized that he has like bags and bags and tons of this dust just piled over each other in one corner of the factory, taking up precious real estate. He's always bursting with ideas, and I thought he needed a lot of real estate. And this is precious land that is just being used to dump dust. So the first idea was, what are you going to do with this? Why don't we can we sell it? He's like, nobody's taking it. Nobody will take dust, right? Because it's available and in plenty, and everybody has a problem with it. So then we said, what if we mix it up with fly ash and give it to the local brick manufacturers? So that's where he probably tried it, and that didn't work. So in this entire process, the one thing he asked us was, can you just give me a size of a brick so that he can start with the mold?
You're an architect in Gurgaon.
Yeah, we're an architectural practice based in Gurgaon, which is near Delhi. So I said, that's easy. So we made a little logo of Rhino, and we made a block for him so that he could make a cast of it. So the other nickname that the SPB goes with is Rhino Bricks. So everybody around practically knows it as Rhino Bricks. My office calls it Rhino Bricks. So, that's basically how we contributed in the earlier part. And then all of a sudden, Manish called us and said, I think we've got the secret recipe. So I was thrilled. I was like, great. So now we can get rid of all of that, bags of dust, and we can literally create the master plan as we had envisioned. So he's like, no, but I need you to help me with something else. Luckily for us, they were exhibiting in Delhi for one of the foundry exhibitions. So we got there and we met them, and he said, I have a gift for you. So I was like, great, I'd love to get a free gift. So we drove down and we went to their stall, and, we were actually shocked and surprised to see multiple bricks of different colors. They had just colored these blocks because, all black doesn't look good. So, and then they started making other shapes. So they made some directional arrows, some paver blocks, and so on and so forth. So then that really got us exciting. So Manish said, this is a box for you. Now I need you to go and get these tested out. So I said, yeah, we've got some good testing laboratories in Delhi. So we actually gave a pile of bricks or blocks to a testing agency. And they took their time. They said, we've never received anything like this. And nobody comes to us for a brick test, because bricks are bricks, and, local brick maker makes it, and it's usually ends at that point. I said, yes, but these are special bricks, and I need you to give us a good feedback on this.
So what were they testing?
So they tested it based on the conventional guidelines to compare it against a regular clay brick. That was our first test. So that's compressive strength, warpage, shrinkage, and, the dropping from a distance kind of test. So at what height does it hold its integrity, and at what height it sort of breaks. Luckily for us, it never broke. You can drop it off from 10 feet or 20 for that matter, and nothing happens to the block. It just bounces off. So I got a call from the testing agency, and they were shocked to see the results. So they said, we've never seen something like this. What is this made of? So I told them it's proprietary stuff. I can't tell you. But they were quite excited about it, and they helped us in terms of, giving us good feedback on it. So then I got excited and shared the results with Manish and his team. And lo and behold, it started the process. So we were still sitting and wondering what else can we do with it. And unfortunately for us, I think COVID situation started up, and, we had the country in lockdown. So that's basically where we had a big, huge pause.
Manish, do you have a patent on this? Do you plan to?
Don't even get me started on this. Vidya, I've had multiple discussions with him. It took me over 6-8 months to understand the reason why there isn't a patent on it. And I have begun to understand it, and I respect that. Manish is a social entrepreneur at heart. He will never patent anything. And I like his philosophy that if it is there for anybody and everybody's understanding, and if they have the capacity to produce it, we can help them, we can guide them, do it, because it's doing something good. And it's actually taking a problem and creating a solution rather than taking a problem and creating multiple other problems. And it takes two big problems that's out there in the society, that's out there in the Indian environment. It's everywhere, our surroundings. You look around India and there's plastic like spewed all over the place. So in a sort of philosophical level, it tries to attack two of these problems from, of course, he comes from a foundry background. So he's basically found a material that's sitting in his backyard and tried to tie it with, plastic that's everywhere and sort of create a solution. So in that sense, I don't see that being a patent and, in fact, we got approached by a lot of these material libraries and material sort of organizations, and they were very keen on whether we have a patent or not, because then they could take this product and sell it to their markets. And the moment we said, no, there isn't a patent, they dropped us like a hot potato.
Like hot bricks, no pun intended.
Yeah. Yes, literally. But I think Manish would better explain why we don't have a patent, because, I think it's a beautiful reasoning behind it.
Right. And imagine where the World Wide Web would be if the original people decided to not make it open, right?
Exactly.
And I think it requires vision and giving.
Courage.
And courage, self-confidence that what you're doing, the world is larger than yourself. Is that how?
So there was a patent which we made in 1999, 2000. For me, that was a learning of how patents are made. It was so crude, and I did not enjoy a single moment of that process. Sitting somewhere in Mumbai and writing and making a sketch, I still remember how I made that patent. After that, in 2015, I was part of an innovation program with UNIDO, Global Clean Tech Innovation Program. And it was for energy efficiency. Again, the same question, do you have a patent? I said, no. And they were asking, why you don't have a patent? I said, see, this is whatever I do has got process technology. So even if I give you all the drawings, you still will not be able to succeed if you don't put your passion inside it. And if you're good at it, you might do something better than me. So there are two sides of the story. The moment I put a patent, I'm blocking development.
Right.
One thing which I understood. Second, when you have a patent, your mindset switches to valuation and you forget what you started to do. And I've met innovators who have been working and, I want to get a patent and I want to get a valuation. And 5 years, their product is still lying where it is. So the entire story is lost. You lose the storyline and you start running after something which you were not even thinking to do. So why get diverted? And one more thing which I realized, that when we had the lockdown in March, the first thing which I did when everything was stopped was file an application in Solar Impulse Foundation as a clean and efficient solution. And when I was doing this, I started understanding that the volume of this business is way beyond my capacity. So even if I don't patent, I will still not be able to do even 2% or 5% of the market size. So why the hell should I patent? I'm not that big enough, and why hold it? So there are a lot of philosophical and also business thoughts behind not having a patent.
Yes, right. In some ways, you spread the message, and more people do this, and you're able to maybe even do more business with this.
Actually, it's the other way around.
Yeah.
So there's been one startup, I would say, who tried to plagiarize this in Ahmedabad. And I said, you have open access, you go ahead. And I'll be very happy if you're able to do it, because I know what it takes to do this. I mean, it took us 3 years to reach where we are. And it's not going to be an easy walk just taking this. It's a business model. It's not only a technology. It's a business model we are talking about.
Right. So it's not easy unless you are completely committed to it and driven and know the whole process.
I just want to give you a little update on this. And, so all of this was happening at the beginning of 2020. And we were almost like gearing up to go to the next level of testing. Like, for example, we had tested this brick in terms of its compression specifications, compared it to a regular clay brick. Now we wanted to test out whether we can do this indoors, like, make internal partitions, make room divisions, and so on and so forth, because that's the next progression coming from an architectural background. So I went back to the testing agency and they said, we are now going to need 150 bricks. So I was like, okay, great. So I let Manish know, and he's like, okay, we'll have to send a truckload, because they are going to create an actual room with these bricks and then set it on fire. So they do all kinds of testing. But then, the country went into lockdown. But that did not dampen our spirits. And I think around April or so, I told Manish, I think we need to put it out on the web in terms of what we are doing, because let the world get to know about it. So we did a small press release and I posted it on all the architectural websites that I have access to. And believe it or not, it just exploded. I mean, after that, it was practically trending in all kinds of social media, all kinds of websites. We started getting mailers by the hundreds from all different parts of the world asking more information about this and so on and so forth. So that has basically helped us. Manish and his team have now created a separate website, and then it began a separate offshoot into what else can we do. That's like a version 2.0. So his team of innovators are sitting in Anand and actually working out what else can come up of it. And he's more than happy to share the dough, if I can call it that, if people want to make whatever they want to make out of it. Because we come from the architectural background, we are trying to create a set of architectural products out of this. Another team sitting and making lifestyle products out of this. They are already making like tables and stools out of it. So it has now transformed into a life of its own. So it's almost like a tree that's mushrooming wider and wider, and whatever you can think of, it's possible. And the good part is we can, test it out with them. And because they are primarily a forging industry, they have the know-how in terms of what can work and what can't. So it makes it that much easier.
So what about the machines? Did you have to design the machines to make it, the tooling, and that must be like...
If somebody listens to how we did it, then it's going to... Because we started with a small mixer, with a small motor, and we used to mix manually with an open burner. So one of the advantages which we had was being a machine builder, manufacturing machines. We were able to build contraptions within our factory. We had a press for straightening things. We used that press for making blocks, and we used our mixers, and we kept on evolving. So we went from initial process validation. So we started with a small contraption. We had this advantage of building machines. And when we saw this video about mixing dust and plastic, so we started with a small contraption, small mixer. So we went from process validation initially when we made those sample blocks. Then we progress into economical viability. So the transition is, if you look at the innovation stages, so there's a technology validation and there is a manufacturing validation. So there are different stages. We call it TRL1, TRL2, TRL3, TRL4, 5. So we are at around TRL5 where we have made prototype, and we are at manufacturing level also 4 or 5 where we have been able to establish the processing costs. So all the machines, designs, whatever we did has been done in-house by Rhino Machines. Initially, we bought some of the machines from outside, which was the press or the shredder for the plastic, because that was not our core product. And there were solutions available. What was not available was the machine which is mixing this and creating the dough. That's where we put all our effort in R&D and did not spend time much in the other accessories which could be bought from the market. But now, after having done that, we made our own press, which is much better than what is available in the market. And we are now making our own shredder because what is available is not able to meet what we want. Because we also want to reuse whatever waste is generated from the SPB itself. So the mixture should also be crushed after it is broken off. So we are trying to build that machine now.
See, this is the part where I actually get really excited, because for me, if I build a building with the SPBs, the building blocks remain timeless. So, for example, I built a house of my liking, right? My generation, my liking, I build a house. So let's say tomorrow, 20 years from now, my son comes in and says, I don't like this house my old man built me, but I really, can reuse some of these things. So the beauty about the SPBs is that I could literally send it back to the shredder, recast them, remold them into another shape. And then that takes, a new life altogether. Now, this thing can keep repeating itself over and over and over again.
So you're taking a really toxic substance and then mixing it with another toxic substance, which is plastic, and you're creating this. So have you tested it for any VOCs or any other emissions or which come out of it?
No, we have not.
Or does it get sealed enough with plaster or gypsum boards to mitigate it?
So there are two parts of this. One is the emission during the process of molding. or making the shape. And second is after having made the product. So during making anything, when you're heating plastic, of course, there will be certain level of fumes for which you use the normal scrubbing system and you absorb whatever emissions are there, not allowing it to go into the air, which is normally used for any plastic injection molding or any of those processes. So these are all proven. There's a testing which is yet to be done. That will be, of course, done in due course of time as we stabilize the process. The second part, I don't think we have been able to test, and Shridhar can tell me whether it can be tested or not.
Yeah, so like I said, I'm still waiting for the truckload of SPBs to reach out because there's multiple tests. This is something very common. We keep getting this as a query. What about, substances that are released when it comes in contact with heat and so on and so forth? So a lot of these questions will actually get validated, hopefully once the pandemic sort of stabilizes. Because at this point of time, there's too many variables in place, and unfortunately, we are not in a position to, test out everything to the extent that we would like it to.
But we have stopped producing bricks. We have shifted to other shapes.
Yeah. Exactly. So the brick was just a start of the process.
Yeah, no, I'm not producing bricks anymore.
But I know for a fact that
you're not producing bricks anymore.
No, but you will have to produce bricks, Manish. I am going to make sure you produce bricks because very soon our next commissions will be made with SPBs after we get everything done and tested and ratified by the laboratories.
So somebody will have to pay out of their nose for the brick.
No problem. We'll make custom bricks, right? That's the beauty of it. I'm sorry, I do keep getting queries from my friends and colleagues in the architectural fraternity, and they're like, can you send me these bricks? How much do they cost? It's like, please don't see these bricks or SPBs as a comparative to your reg bricks or your cement blocks, etc. Design something customized and then let's talk. Because that's the beauty of this. It can give you phenomenal shapes and sizes. Make that one architectural marvel that you want to stand out for now. So the cost justifies its creation. And that's where I'm going to come back to Manish and say, we have to make this.
So then let's talk about the cost. How much more expensive is it compared to the red brick or the concrete blocks?
So cost is a very vague idea to compare. So how do you make a cost comparison is where the question starts. Are we talking of a commodity cost comparing only what I buy off the shelf? Am I talking of life cycle cost? Am I talking of as-built cost? So generally, as normal human beings, we are all used to talking of only the initial cost, whether it's capital or it's a commodity. Oh, this is costing 3 times more. So for example, in Anand, the red brick will cost 5 or 6 rupees for one brick. And we initially started that we thought we would be able to put this brick at 10 rupees.
So 5 or 6 rupees is about 10 cents a brick.
Less than 10 cents, I can say.
Less than, about 8 cents a brick.
8 cents a brick.
Okay. And you thought you could probably do it for 12 or 13 cents a brick.
10, 12 rupees, which also was more expensive. And people, no, it's too expensive. The strength is 2.5 times, of course. Its longevity is much better. It's got so many other sustainable advantages. No warpage, no shrinkage, no water absorption.
No warpage shrinkage. That's a very big deal.
Yeah.
That's a very big deal in India.
So then when we started to get into the actual economics, the cost of manpower, which was not foreseen, is higher. And it's not a very high production technology, product line. So you are saying that I'm producing 40 bricks per hour or 50 bricks per hour and I'm engaging 4 people. Then my cost of manpower itself will be 6 rupees per brick, which is not affordable. So, but if I go to the metro cities, there the cost of the brick is 20 cents. So 14 rupees, 12 to 14 rupees. So there'll be different ways of looking at economics. We made a calculation of making a wall. So with this brick, you don't have to plaster, not necessary. So we made a calculation with our contractor. What if I don't plaster? Will it be the same? And we have made some thermocol models, not yet. We have not been able to produce some interlocking bricks, self-interlocking. So as Shridhar said, we'll have to look beyond a conventional 9 by 4 by 3 brick. It needs to be something which is differently shaped, differently constructed to make it cheaper as a life cycle cost or as built cost. Right? Today, this material, I know if anybody wants to put up this plant and make it viable, the first thing I tell them is if you are not able to sell this product at between 15 to 20 rupees a kg, then you'll not be able to sustain the project. So let's not talk of bricks.
So what about economies of scale? Like, I mean, you just started, and of course the pandemic is there, and even now we are recording this on April 22nd, 2021, a whole year
Yes.
and 1 month after the first lockdown. The first lockdown in India was on March 23rd, I think. So going forward, I mean, you've not had time to scale this and, improve the process enough to bring about economies of scale and scope.
Actually, it's the other way around. We got so much time to think and work on this that today we are ready to scale it up. So when people thought pandemic is a problem for us, two sustainable product lines, which I have. One is the SPB, and the second was for the mask, which I sent the article to you in the morning. These two have been creations which have developed during the pandemic because we found so much time to work on it. We know how to scale it up. We know what are the challenges. We have done our complete study of which products it can be put into, how it can be put into, what kind of business models will work. And we did a webinar on putting across actually four. Shridhar was one of them. So how can an architect look at this product? How can an NGO look at this product? How can a vocational education institution look at this product? And how can a manufacturer like us look at this product? So it has multiple perspectives when you look at this material, and it's all about material technology, as Shridhar has been saying.
I mean, it's really going to start exploding the moment, we take it to a larger industrial base, for example, like a Tata Steel or a cement plant, where, like Manish had earlier pointed out, that they've been successful in integrating other waste products as part of the SPB family, if I can broadly say that, a cement plant, for example, has its own sort of housing colony next to it, right? Typically, they come with very large infrastructure. Now, if the cement plant or any industry produces X amount of waste, the housing colony also produces X amount of plastic. Both of these can be combined together to create a much larger infrastructural push or infrastructural, requirements that, say, the village nearby would have or need, and those can then be extended out as free building blocks for them to, satisfy their infrastructural needs. So there is a whole lot of chain reaction that can be generated off of this, which is waiting to happen. I mean, once the pandemic sort of sets in.
And India has these traditional brick builders. Maybe in the rural areas, you can employ or retrain the brick builders to do more mechanized ways of production.
To me, this project today has so many multiple aspects when I look at it. And I've called it, this is a magnet which attracts. It's including you who got attracted to this. Because different people from different facets of life have been attracted to this. Be it youth, be it government, be it institutions, be it architects, be it companies like Tata Steel, or we are discussing with Hindustan Composites, we are discussing with Excel Rubber, want to put up this project. I was discussing with the sugar industry, what can we do with our dust. So it has got something which can give a lot of creations. But in all of this, there's something which I found a very strong missing link, and was the interlink. So we say plastic is a problem, right, for environment. And actually for us to get plastic is the biggest problem to make this brick. So you'll be surprised of the key. If I take the list of problems, the biggest problem is to have access to waste plastic. Biggest problem. That problem is not a problem coming out of the system. The problem is coming out of our behavior. It's a problem coming out of society awareness. So I live in a good society with educated people, and I'll find plastic lying on their plot outside their own houses. So if I can't educate people, then God bless us.
Where do you think this project will go?
So having experienced the ups and downs and going through the entire process for last 3-4 years of developing this project, in this same period, I was also exposed to or given access to a United Nations program called Empretech, which was about building sustainable businesses through understanding what goes behind building a successful business. And I've been documenting my journey through the entire SPB project and a lot of other projects. So when I look back, I find that if I were to work with somebody, I start putting qualifying remarks. So whether their purpose aligns with my purpose or not. So it's not a plain brick and mortar selling of plant and machinery. So if I want to take this project further, the first question I ask is why you want to do this project. and I dissuade them from doing this project, that it will not work. So filtering people who would really take this project further and finding the right people who would be able to take this technology further is the first step which I take. And I use this framework which is available with me to understand the risks involved in this project. And one of the documents which I put in my presentation is on the risks which are there in this project. And when I presented to government of Uttarakhand, I was talking about, see, these are the risks in this project. So think before taking the risk. So understanding risk is one. Second, there's a lot of socially sensitive people, environment sensitivity, which is there in the youth today who approach us, who want to do a startup. What we have told them, and because I have seen that startups are not able to succeed so easily, we have devised a policy of incubating startups with us. So you come here, you can work with us, we'll show you everything, we'll help you build the business model, we'll help you find what products you can sell, and ensure that you don't fail, because your success is my success. And build the value chains. So if you go back to the basic principles of Empretech, its key tagline is integrating developing countries' SMEs into global value chains. It's talking about integrating people. And this project is about integrating multi-dimensional people together. So you have society, you have educational system, you have institutional bodies, you have the industry body. To stitch them together, it's necessary to all of them to have a common language or understanding. And that's what is the way forward for us. Get them together to speak the same language.
I mean, this is what he's pointed out is actually true. There is also a fundamental problem in India. Everything is free until there is a value added to it. So the moment the plastics gets its value, that it's being added to this creation of something else, it's no longer free anymore. But at the same time, it still doesn't stop us from saying, okay, what about creating a drive and then donating it? So there's a lot of, like Manish said, it's a magnet, but it also involves a lot of policy and issues. Like, for example, if the local administration gets involved and says that we are going to do a plastic collection drive and then make sure that this particular plastic is donated to a CSR that is funded by an industrial town nearby. So then, a lot of those things can start plugging in the holes that are currently open and loose in some aspects. So it requires a drive that is much larger, and it actually has participation in all aspects, right from the individual to the society to the administration. Everybody sort of needs to reassess and focus themselves in that direction, and then there could be a huge difference.
On that very, very positive and uplifting note, thank you, Manish Kothari and Shridhar Rao, for coming on Mindful Businesses.
Thank you so much. Thank you for having us and listening to our banter.
Thank you for having us. It was a pleasure talking to you.
No, it was most enlightening. You're listening to Vidya Iyer on Mindful Businesses. If you're a creator of a mindful brand or would like to recommend a mindful brand to be featured on our show, send an email to info@mindfulbusinessespodcast.com. Subscribe and listen to us on your favorite podcast listening app. Remember to rate and review us on Google or Apple Podcasts. To learn more about this and other episodes, check out our website, mindfulbusinessespodcast.com. If you learned a thing or two from this episode, share it with one friend. This is Vidya Iyer with Mindful Businesses.